Question 3. The complex numbers z1 and z2 are given by those two expressions where a is a real number. Express z1 in modulus argument form. So here we go. Z1 is 2 minus 3i. So the modulus of that, the modulus of z1 is the square root of 2 squared plus negative 3 squared. So we've got, what is that, 9 plus 4, that's root 13. And if we think about the argument, then it goes across 2 and down 3, so there's the argument of z. So when we think about the argument, tan of theta is 3/2. Grab our calculator and do, let's be in radians here. We're going to do inverse tan of 3/2 and come up with 0.983 radians. So the argument of z, well, that is clockwise from the horizontal real axis, so that is minus 0.983. So z1 is root 13 cos theta plus I sine theta, and any equivalent form to that would be acceptable. The real and imaginary parts of part 2, find z1, z2 in terms of a, writing your answer in the form c plus id. So part 2, we are going to do z1 times z2, which is 2 minus 3i, that was z1, times z2, a plus 4i. Now that's going to give us 2a plus 8i minus 3ai minus 12i squared. 2a plus 12, that's collecting the real parts together, and 8 minus 3ai. Let's put a bracket around that. There's the form c plus id. Part 3, the real and imaginary parts of a complex number on an Argand diagram are x and y respectively. Given that the point representing z1, z2 lies on the line y equals x, find the value of a. Well, if this point lies on the line y equals x, that implies that the c equals d in what we were looking at. In other words, 2a plus 12, the real and imaginary parts are the same size. So 2a plus 12 is 8 minus 3a, giving 5a is negative 4, so a is negative 4/5. And finally, given instead that z1, z2 equals the conjugate of z1, z2, find the value of a. So what we got, z1, z2 was 2a plus 12 plus 8 minus 3ai. The conjugate of that is 2a plus 12 minus 8 minus 3ai. If they are equal to each other, then the bit that we're adding there and subtracting there must be the same. In other words, it must be 0. So that implies that 8 minus 3a is equal to 0. So a is 8/3. There we go, and that's maths.